Okay, let's jump right into this explainer. When we talk about decarbonizing transportation, you know it's incredibly tempting to look for that one silver bullet. We all kind of want to believe that we can just swap out petroleum for a plant-based alternative and boom, problem solved, right? Well, not quite. As we're going to see today, by looking through the lens of industry sustainability standards, the truth is a much more complex and, frankly, a way more fascinating carbon equation than just dumping some plants into a gas tank.
So you might be wondering, if biofuels come from plants, why aren't they automatically carbon neutral? I mean, it seems completely intuitive, right? If plants absorb carbon dioxide from the atmosphere as they grow, burning them later should just return that exact same carbon. It should be a perfect net zero impact. But here's the catch. True sustainability isn't just about what comes out of the tailpipe. It is a rigorous cradle-to-grave measurement. To genuinely understand a fuel's impact, we have to account for the heavy diesel machinery used to harvest those plants, the fuel guzzled to transport tons of raw material, and the incredibly intensive industrial processes required to refine the whole shebang into a usable liquid.
And this is exactly why we have to completely rethink our carbon math. Traditional fossil fuels, they operate on a one-way street of emissions. We're extracting ancient trapped carbon from deep underground and just venting it into our current atmosphere. But the biofuel net carbon cycle, it functions much more like a dynamic carbon checkbook. It's this continuous loop of debiting and crediting emissions throughout the fuel's entire lifespan. So the plants absorb carbon as they grow, right? That creates a massive initial credit. But then every mechanical and chemical step that follows acts as a debit against that credit, just constantly chipping away at the environmental benefit.
To really put this into perspective, let's track a single unit of fuel on its journey. Day one starts with feedstock cultivation, and get this, that even forces us to factor in indirect emissions, like land use changes if a forest was cleared for agriculture. Fast forward to day 120 and we've got transport, hauling all that bulky raw material to a facility. Then, right on its heels around day 125 is the super energy-intensive refining phase, where those raw plants are actually converted into combustible fuel. Finally, by day 130, we hit the end-use exhaust. The emissions from every single one of these phases literally have to be aggregated together to find the true environmental cost.
The absolutely crucial point here is that modern producers are graded on an exact scientific metric. Sustainability standards define life cycle greenhouse gas emissions as the total aggregate quantity of emissions tied to the full fuel life cycle. This captures direct emissions, significant indirect emissions, everything from generation right through to the consumer using it. And it even adjusts the mass values of different gases to account for their specific global warming potential. The final score that these companies have to answer for? It's measured precisely in grams of CO2 equivalent per megajoule of energy produced. That metric right there is the ultimate equalizer in the energy industry.
Now, this isn't just some theoretical environmental science exercise. We're talking hard corporate accounting. Under the SASB industry standard, companies in the biofuel sector are formally mandated to track and report this exact metric under their life cycle emissions balance. They literally have to report those grams of CO2 equivalent per megajoule broken down by specific biofuel type. And why does this matter so much? Because the massive global growth in biofuels is heavily driven by government energy policies. If a corporation wants to play in those super lucrative markets, they have no choice but to publicly prove their life cycle math.
Of course, not all biofuels are created equal, and your starting ingredients drastically alter that carbon math. The standard actually categorizes production into 4 distinct types. You've got your basic, renewable fuels derived from standard biomass like corn, but then it scales all the way up to advanced biofuels, which use stuff like algae, animal manure, or, believe it or not, leftover wine lees. Then there's biodiesels, relying on waste cooking oil, and cellulosic fuels that extract energy from complex, woody forestry residues and husks. Each one of these source materials carries a vastly different starting footprint.
So with all those wild feedstocks in play across huge agricultural landscapes, where does a company actually have real control? Well, we need to zoom in heavily on the refining phase. Producers might just be buying their raw materials from widespread distributors, but what happens inside their own facilities? That is 100% in their hands. Because of this, refining is exactly where the narrative shifts from just passively watching a supply chain to executing active, high-stakes corporate strategy. Biofuel producers are definitely not just victims of their supply chains. They directly influence net emissions right at the refinery level. It is their ultimate leverage point. Remember, the whole goal of major renewable fuel policies is to reduce net greenhouse gas emissions compared to traditional fossil fuels. That means producers absolutely must optimize everything under their own roof. Think about the intense heat, the pressure, the distillation in these massive industrial plants. If that refining process is an energy hog, it completely wipes out whatever carbon credits they gained from using a plant-based feedstock in the first place.
To actively shrink that footprint and manage their carbon ledger, producers have to be strategic. First, they implement incredibly strict energy management on the refinery floor to cut out wasted power. Second, they're constantly introducing process innovations, finding cleaner, smarter ways to extract, ferment, and distill. And third, they strategically procure feedstocks that naturally have lower emission profiles right out of the gate. And here's the kicker. When a company executes these strategic moves perfectly, the results go way beyond just being good to the environment.
It creates this incredibly powerful pipeline where massive environmental benefits directly unlock massive economic benefits. By achieving deep life cycle greenhouse gas reductions, these fuels officially qualify for advanced biofuel mandates set by governments. Meeting those specific regulatory thresholds instantly spurs revenue growth because the law essentially guarantees buyers for the absolute greenest fuels. So, biofuel producers who can cost-effectively reduce their net carbon emissions this way, they gain a huge competitive advantage and capture serious market share in a highly regulated industry. It's a total game changer.
Which brings us to a really fascinating final point to ponder. The next time you're at the pump and you see a renewable fuel sticker, think about this massive, intricate supply chain equation. You now know it's not just about what burns in the engine. It's about the tractors, the transport, the land use, and the refining energy, all measured down to the exact gram of CO2 per megajoule. And it really forces us to ask a much broader question. Are we holding every sustainable solution out there, from electric vehicle batteries to solar panels, to this same rigorous cradle-to-grave standard? Because, as the biofuel industry clearly proves, true sustainability isn't just found in the final product, it's found in the entire life cycle.